Alright, so I wanted to give y'all a few tips on Module 6, Lesson 3, Assignment 1. And depending on how long this takes, I may end up splitting it into two parts, so we'll see how it turns out. On this first question, one thing for you to keep in mind when you calculate your answer, this problem is assuming that the frictional work done is in a negative direction. So when you have your final answer, you'll need to report it as a negative. That's question 1. I think the power problems are fairly straightforward, so I won't talk about those. Question 5 is a fairly complicated question in that you have to realize that the skater actually has kinetic energy at the beginning and then a reduced amount of kinetic energy at the end, but all the while the skater is pushing and doing some work, and friction is resisting that as well. So you have to realize that in the end, to account for the difference in all of these things, you have to have a change in gravitational potential energy. So that's the general idea of how you'll work through that. In the initial situation, you have the amount of kinetic energy related to moving at 3 meters per second, and then at the end you'll have kinetic energy related to 1.7 meters per second, but you also have to account for the positive work you did, the negative work done by friction, and then the difference between the initial and the final would be the gravitational energy. I believe these problems are similar enough to those, to the example in the notes, so I won't talk about them. Okay, this situation, you have to realize that there's a transfer of gravitational potential energy to kinetic energy. The launch is a horizontal launch as indicated by the velocity vector here, so you have to use energy to figure out how fast it's going, and then you use projectile motion to figure out how far it goes or what the range or the distance is. For this one, the skateboarder is going to have gravitational potential energy at the top of the half pipe, and then he'll have kinetic energy, or she'll have kinetic energy, whether your skateboarder is a guy or a girl, at the bottom. And what you'll have to realize is that you can use that to calculate the velocity at the bottom, and then you'll have to recall that since this half pipe is a circle, that centripetal motion would apply here, and you would have an upward normal force and a downward force of gravity, and the centripetal force that you could calculate using the velocity would tell you how much larger the normal force would be compared to the force of gravity at this point, in order that the skateboarder would continue moving in a circular fashion. With this question, you know the kinetic energy of the block initially, and you know that it compresses a spring and there's some friction. So the kinetic energy at the beginning will be equal to the work done by friction plus the energy stored in the spring, and that'll allow you to calculate the force constant of the spring. In this problem, energy may actually not be the easiest way for you to solve this in either case. I'm going to explain it with energy. You can also look back and figure out how to do it using Newton's laws. But basically, the M1 experiences a gain of gravitational energy, while the M2 experiences a loss of gravitational energy. And then you could figure out the speed of the system, because the entire system will have a kinetic energy equal to the change in gravitational potential energy. After you figure out the final speed of the system, then you have a situation where you have this M1 block that's been launched up, and it'll keep moving upward for just a little ways, and you can use one of your kinematic equations to figure that out, or figure out how high it goes. Alright, so for 15, the energy is initially stored in a spring, and you have to figure out how far the spring is compressed. In the end, some of that energy that was stored in the spring is lost to work done by friction in the rough area, and then after the rough area has kinetic energy as a result of this velocity that it still has. So what you can say is that the energy stored in the spring would be equal to the work done by friction plus the kinetic energy after it passes over the rough spot. And on this one, you just have to remember that the work done is only by the component of the force in the direction of motion. So you'll need to find the vertical and the horizontal components. Well, you won't need to find both of them. You just need to find the important one. Think about which direction the block is moving to figure out which component you need to use, and then use the work equation, force times distance, to get the amount of work for this question. So that concludes this tips and pointers, and hopefully you find that helpful.